join of the Born Haber cycle. So the equation, we are forming calcium oxide from the elements in their standard state. So that would be calcium plus O2 to give calcium oxide. Clearly, we have two oxygen on this side and one oxygen on this side, but we are forming 1 mole of calcium hydroxide. So I'm going to put half in front. So that's the equation. All right, so with that said, let's go to the Barnabas cycle now. So let me put, all right. So we're going to form calcium oxide. So I'm going to have calcium solid plus half O2 gas. Alright. And then going up, I'm going to atomize calcium. So that would be Ca gas plus half O2 gas. And then I'm going to do. All right, somebody tell me, after atomization of calcium, what should I do to calcium? Anybody?
First
Ionize it.
ionization
All
energy.
right. So Ca plus gas plus E plus half O2. All right. And then after first ionization energy, what should I do next?
The second ionization energy.
All right. I have to move this for a sec. All right. So it would be Ca2 plus 2E plus half O2. And then after that, what should I do next?
Atomization of oxygen.
All right. Excellent. All right. Let me just bring the arrow up above this. So I will have Ca. Tell me what I should put up here.
Ca2
Mm-hmm.
plus 2 electrons
Mm-hmm.
plus O.
Even though I left out the state symbols here, don't leave them out, alright? Keep your state symbols. Alright, so after, right, so we have the oxygen now, right? So the calcium 2 plus the 2E plus O. What happens next?
We draw a line come down. Well, go across then come down.
Alright, and what?
Lattice energy?
No, we're not at
No.
lattice energy yet. What are we
No.
doing here?
Electron affinity.
Alright, so we're doing first electron affinity. Alright, hold on. I'm going to draw this. Due to space, let me just come down here.
Sir,
Yes,
what did you do for the calcium, not the calcium, the oxygen?
we atomize it. So remember, it was a diatomic molecule, O2. Ignore the half in front. That is just for balancing the equation. So we're changing it from O2, which is a molecule, to an atom. So remember,
Okay,
it is
sir.
right. So it is the atom of oxygen that will accept the electron, not the molecule. That is why we always atomize the diatomic molecules so that we get the atom, right, in the sorry, in the gaseous state. Well, it is already a gas. All right. So after that, now it is going to gain 1 electron first. So here we would have Ca2 plus E, because oxygen is going to accept 1 electron. So it becomes O minus. So after first electron affinity, what will we have?
second electron
Alright.
affinity.
Normally, this arrow here is above this one, but due to the space on the screen, all right. So we would have Ca2 plus O2 minus. All right. So when O minus accept this electron, we're going to get O2 minus. So remember, you don't do the long arrow coming down until you have both ions with the correct charges. So until you have Ca2 plus and O2 minus, you do not draw the line coming down. All right. So that is the Born Haber cycle. For calcium oxide, this did not require any calculation, but here is one now. It came last year, which required calculation. And based on what Cape did last year, we're not leaving anything to chance. They repeat same topics from 2022. So don't be surprised if you get back a Born Haber cycle question, all right? So we just have to know everything. All right, they are changing things up on us. All right, so this was one where all you had to do was construct it. So let me switch now to the 2023. Download this. Um, all right, let me share this stuff. All right, so it says construct a Barnabas cycle for the formation of lead 2 fluoride, showing clearly using equations the steps of enthalpy changes involved. So that's 6 marks. Let's scroll down, and then after you construct it, so you're constructing lead fluoride PbF2. Can you see the data in the table clearly? Are you able
Yes,
to
sir.
see it? All right. So after you do that now, then it says use the data in table 1, calculate lattice energy for lead fluoride. So again, no assistance, just go ahead. So 5 minutes, let me see, 5 minutes to construct a cycle, and I will give you a next 2 minutes to do your calculations. So that's 7 minutes. All right. So here's the data when you're finished constructing the cycle. And again, you can WhatsApp me your answer if you want me to check it. I'm gonna pause the recording. Alright, so yeah, so I'm not the one playing it, it's in the community. Yeah. Alright, bum bum bum. Yeah, let me just zoom in on this. Alright. So we're forming lead fluoride. Alright, so bum bum bum. Alright. So alright, so PB solid half F2. Should I have half F2?
No, sir.
Why?
Because 2F, you would put half, would I
Alright,
represent 1 if you put
because
the.
the yeah, go ahead.
So I was just saying, if you put half, it would represent 1.
Right. And the compound as in 2 fluorine. Right. So it stays as F2. Right. And of course, you would put like your delta H of formation, right? Put in all your symbols, right? And this should be a gas, right? And then after this, we know if you want to atomize fluorine first, that's okay. But I choose to do the metal first. All right, so we atomize lead, and then we do two ionization energies of lead. So Pb plus E plus F2, and then Pb2 plus 2E plus F2, and then we atomize fluorine. So it now becomes Pb2 plus 2E. Remember when I just did this topic, I told that any amount of fluorine is any amount of the element in the compound, that's the amount to put here. So two fluorine is in the compound, so we need two fluorine up here. Mm. How many electron of affinity will we have? One or two?
One.
One, right. So Pb2 plus 2F minus. So it's not like oxygen that is O2 minus. Two fluorine atom each gaining one electron. So that is why the electron affinity you have to times it by two, because it is two fluorine atoms each gaining one electron. All right, and then of course you draw a line, come all the way down, all right, and this is your lattice enthalpy. All right, so in terms of numbers now, the enthalpy of formation here, negative 664, atomization 195.20, all right, then 716, then 1450, then 79, and then here now it would be negative 328.16 times 2, uh, which is equal to negative 656, negative, just, which is equal to negative 656.32. Alright, so it's two fluoride ions here times it by 2. Alright, so remember now, how do we do this? How many roots, how many R's do we have on the diagram? R1, R2, R1, R2, R3. How many R's?
Three, sir.
All right, can you tell me how I get the where we get each of them?
At the first one is at the enthalpy of formation.
All right. If you want to call it R1, that is okay, but I'm going to call it R3. All right. So enthalpy of formation, I'm going to call it R3. All right. And then where do we get a next R? All right. So it's everything from
The atomization
mhm,
of to the electron affinity.
right all the way to electron affinity. So let me call that R2. All right. No, let me call it R1. All right. So R1 is equal to, did I write it down? 195.20 plus 716 plus 1450 plus 79 plus negative 656.32, and that gave me 1783.88. So that's R1. And then this is R2. So what is R? So we're trying to calculate R2, right? So what would R2 be equal to in terms of R1 and R3? R2 is equal to,
R1 minus R3
all right, hold on. So let's check. All right. All right. So which two of them are going in the same
minus
direction?
R2.
Which two are going in the same direction?
1 and 2.
All right.
R1 and R2.
Right. So R3 is equal to R1 plus R2. Or if you want to say R1 plus R2 equal R3, it doesn't matter, right? So if you want R2, all right, or let's R1 plus R2 equal R3. So if you want R2, you bring across R1. So it is R3 minus R1. Let me see if I have space. All right, no. So it is R3 minus R1. All right. R3 is negative 664. Take away 1783.88, and I got, where was it? Negative 2447.88, right? And I also specifically did it with just the one electron affinity, and when I did that, I got negative 2776. So that is why I said anybody that got negative 2776 would have been on the correct path. It's just that we would multiply it by 2. All right, so all right, that is how we would have done, should have done this one. All right, so you should be good with Born Haber after this. All right, so tomorrow again, anyway, again from, yes, something similar to this time. All right, we do the heat of solution and neutralization and hydration. All right, so I'm going to end it here for tonight.
So are you doing class Friday?
More than likely, I intend to. Yeah.